So we talked about Security Onion. What we're going to do today is just play around with a couple of the tools that are inside of Security Onion and just kind of show you like, hey, here's a good way to play around with this. So what we need to do is open up web browser, which I think is Chromium. So there we go. Go to share.ilab.dsu.edu again. And then inside of there, there's an nsm01.pcap.zip. So we need to download and unzip that. And that's what we're going to play around with. I'll pause for a second to give everyone a brief moment to find that. I'll open it up here where it's going to be easier to see. This one. So we shall download and unzip said file and have this little PCAP here. So the way Security Onion is set up, it only wants to listen to traffic coming in over a live network interface. It's like not gonna, you can't like feed it a PCAP necessarily. I guess there's a couple of the tools you can feed a PCAP into. So what do we need to do if we're sitting here with a PCAP? Does anyone know the tool to go from PCAP to traffic onto a network interface? Okay. So there's a fun tool called TCP Replay. So what TCP Replay does is opens up a PCAP file and actually reconstructs it and sends it out onto a network. So you can go all the way to the point of like taking all the traffic in a PCAP file and repointing it to a new IP and sending it out. And TCP Replay is generally smart enough to look through and like find all the three-way handshakes and regenerate all the like, so it won't necessarily send the direct SYNs, it will make its own and then update all of the data packets inside and send it out over a network. So it is an interesting way to test intrusion detection systems because you can take like, you can get PCAPs of different types of generic attacks and just send it. It's going to be more or less benign and hope that your IDS detects it. The other cool thing you can do with this is any sort of network replay attack you can actually do with TCP Replay. So what would a network replay attack be? Yeah, so we're capturing traffic that like isn't dynamic, it's just static all the time. So when we replay it, we can get cool things to happen. So a cool example of that is the strike plate controllers on a lot of doors. So case in point, I get DSU, our network that the hand scanners and door controllers or clickers, whatever you want to call them, work on, is very much so isolated because they suffer from replay attacks. So if we can actually get a Wireshark capture of the server telling a door to open, we can take that capture and replay it out onto the network, and the door will just open. You can sit there at TCP Replay hitting up and just keep like the buzzer on the door going all day because you just keep sending the engage relay command to it. So it's the replay attacks are nowadays, like you used to be able to do really easy replay attacks against Windows and log into it and stuff like that. Windows is a little more challenging with that now because of a fun thing called Kerberos, which makes tickets that are time-based, so the ticket expires, then you can't replay it anymore. So there's that, which is why if you ever play around in Active Directory land, if you have servers whose clocks are way off, if you're off by like a minute, it's probably going to be fine. But if the network's time is varying, like this server thinks it's currently 949. This one currently thinks it's 920. Those servers in Active Directory are going to just fall apart because their Kerberos tickets are always just going to be broken. So now, though, we see it with just, I'd call ghetto devices, so like a door clicker or thermostats, stuff like that. Probably even webcams, I would venture a guess. So there's that. So for TCP replay. Oh, within? Oh, no. No, definitely can't do that. Well, it's not like forbidden, it just won't work. So, yeah, if you have a VM in the lab, you will not be able to get to that website. Does anyone have a guess as to why? No guess. So, it is a NAT reflection problem. There's a firewall rule that allows it to get out, but NAT is actually what breaks it. Because when your VM in the lab hits the router says, oh, I NAT these going out to, or I NAT traffic coming from the VM network. So it replaces the address, the destination address. Then it sees, oh, that address is actually this server. So it sends it to the server and does the NAT on that. Because when you're resolving it, you're resolving a public IP. NAT changes it to a private. The server gets the packet, replies to your private address. The router says, oh, private address, sounds good, sends the packet back. Your computer has sent a SYN to a public IP and received an ACK from a private one and goes, no, I'm not doing that at all. Drops it and you can't connect. So that's why we love NAT. What's that? Yes, there's a couple ghetto ways. You can add like 5,000 more NAT rules for like every circumstance which could ever happen, and make what's called reflexive NAT. So you basically say like, don't NAT these things, but do NAT these things. Or you can run 2 DNS servers. So you'd have a DNS server running publicly, which would have all of your public addresses in it, and then you'd have another DNS server internally running all of the same IP addresses, or same domain names, but with their internal private addresses, therefore NAT will never fire. Neither one are very good solutions, but they're solutions to a really stupid problem, because NAT sucks. So, to get around that, I'll just put it in D2L. Which we need to go here, and then we need to go there, and then, oh, if you go to D2L, you're going to get the bonus of not having to unzip it. What a day. Field cannot be empty. Which field? Oh, we need content. Here is the file. Yes. Field cannot be empty. What one? Oh, beats me. All right. And now you should have security onion PCAP. So playing around with TCP replay, we have many different options that we can do. Really, all I'm going to have us do is do a -I for the interface, and don't do ETH0, do ETH1. And we should probably rate limit it a little bit. So by default, TCP replay is going to just give her hell and just spew the packets out onto the network absolutely as fast as possible. You probably want to tell TCP replay to like simmer down a little bit. So I will run this command and then I will put it up higher on the screen because I'm sure none of you can see that all the way down there. Oops. We'll do not capture, we want to do nsm02.pcap. Oh, of course. And I don't know, do I dare go through the world of trying to make the font bigger? Appearance, monospace 12, no. We need, how's 32? Oh, look at 32. Oh, excellent. Excellent. Thank you, 32. There we go. That is our entire command right there. Oh, but there's something missing from this command.
Sudo.
We need to do sudo. Why? TCP replay is like wants to grab a network interface and just pump packets into it without any regard to what it should be doing. That requires somewhat elevated privileges to do. So sudo TCP replay. Then you should be good to go. And we'll run this. There we go. So this is, for this particular capture, there's not going to be anything super radical going on. But if you are attempting to like break into doors and stuff like that, that's where you start to play with like, well, was this successful or was this not successful? Or if you ever are trying to use TC replay to do replay attacks, you have to make sure like some things like ghetto embedded devices like door controllers sometimes don't actually speak layer 3. They literally will just take an Ethernet frame on a switched network with like a random chunk of data in them. They're totally not implementing networking correctly, but that way if you're writing the software on a door controller, you don't have to worry about dealing with IP addresses and TCP and all that nonsense. You just depend on a switch in Ethernet to get stuff to you, which isn't a good idea, but somehow magically just works. It's also why when you look at a lot of embedded devices, like in the case of DSU and our door controllers, when they send the signal from the server to open the door, they send the packet like 5,000 times because they know that they're going to get lost along the way and they don't do networking correctly. So all sorts of fun little things there. So got our traffic sent. Good times had by everyone, right? Got some error.
Yeah.
What'd you get?
Invalid interface name.
Do you have two network interfaces? You could also do TCP replay list NICs, I think. Oh, we need to sudo that. And then when you do TCP replay with a tac list NICs, it will dump out a list of all of the network interfaces it sees. So if you don't have a ETH1 in there, or I guess you could do the old school ifconfig, which does not like the big font. Make sure you have it. You might get troubles if Security Onion is not listening on ETH0. Maybe, maybe not, I don't know. And I guess this all assumes that you ran through the wizard and set up Security Onion. Otherwise, you're just pumping traffic to a random network interface, and it's just going to be like, I don't know, beats me. So that's a thing. So for some rough checks to see what's going on, if you go into the file system and go to the NSM folder, there should be a couple basic data files in here. Trying to think which one we want. Oh yeah. So if you go to sensor data, and then there will be a folder for your particular network interface. So I have Kyle-virtual-machine, so that's the host name of the VM. ETH1, so if you open up that, you should see like things that come in here and tell you like, so here's where it's actually storing the PCAP files of stuff that it found. So you should be able to open up a PCAP file, and it's going to open up.
Is that NSM in the directory?
Yes.
I just have a bro.
You just have a bro and an ELSA folder when you open up your interface or sensor. Sorry. Oh, have you ran through the wizard?
Yes.
You're sure? Like you set a password on Sqguil and everything? No. I would try. So the fun times is run through the wizard again if those folders aren't there. The wizard ends up being, well, you have to run through the wizard twice anyway. But when you go from like flipping from one PCAP to the next to have security onion analyze it all, if you run through the wizard each time and just hit all the defaults or whatever, it will clear out its database each time. So it's a good way to check that basically. I think you can also do if you do service NSM status, there's actually several different pieces to security onion that I suppose you should make sure are actually going up. Another pig reference with the barnyard service. So, anywho, what you should find in here is sensor data. Guessing random, how many of you do have sensor data files? A couple of you. How many of you don't? 1, 2. All right. Let's try to run through the wizard and reboot it. And I'll chill for a little bit so I don't start showing you like, see all these cool things? And you're like, no. Here's one thing we can do. Regardless of having that up and running, there is a nifty tool in there, and I don't know how to pronounce its name, but it's cool. Explico or something like that. So there's a shortcut on the desktop of Security Onion. Regardless of whether the sensors are currently running or not, we can play around with this. So this is a forensics tool for playing around with network captures. So the username is XPLICO, I think, and so is the password, the default anyway. There we go. So we get in here, and it's one of those things, like, I'm not going to lie, it's not like the most, what would a really awful way to say this be? It's not an interface Apple would make. Yeah, see. But if we come in and hit new case, this is for, like, just carving apart network traffic stuff. So this one can do live eating of traffic, or we can just upload stuff. So I'm going to call this CSC438 18 May 9:30. So we'll create a new case, and then we'll go into said case, and we have to make a new session. So sessions are where we're like listening to stuff, so we'll call the session something informative. And then we'll go into the session, and we get this fun little interface that's supposed to be analyzing traffic for us. So if we go to choose file and grab something, actually just for fun I'm going to grab this big one because it has more stuff in it. And hit upload. And give it a couple, what would you say, Mississippis to eat the file and process it. I'll refresh the page. Oh, it is still decoding. So give it a minute. Still decoding, still decoding, still decoding. There's also a live, like, hosted version of this, but I personally wouldn't recommend, like, capturing network traffic and just off your computer and uploading it to a random place to play, because I just wouldn't do that. It's just a... Yes, you have to make a new case, new session, and then go to upload a file. And maybe my uploading of a 12 megabyte file was a bad idea because it's taking a while to think about it. Decoding completed. Excellent. So inside of this, I think in particular, I just grabbed a random file that I happen to have. So let's see. If I make this bigger for you guys to be able to see. Are we ready for this? It's going to be a resolution change in Linux. Going live here. Except I don't know where to do that from. Settings, not system. Oh. Do any of you ever cringe when you change the resolution on a Linux machine? Oh, that one went. Excellent. There we go. So it has a few more, I don't know, options than just Wireshark for going and carving out the file and pulling out statistics and all that good stuff. So obviously it's going to like unencrypted stuff, but when you come through here, pulls out even text messages if you had that sort of thing going on. Yeah, I'm not going to spend like tons and tons of time going through here because it's just not that exciting. But it's a good way to go quick, like visualize what's going on inside of a network trace without having to like open up Wireshark and start cutting stuff apart raw, because that's generally not that fun to do. So you can go through and see all the different images. The other cool thing, if you have people sending email over port 25, so if you're sending email messages over port 25, what does that mean? When you're connecting to an SMTP server instead of port like 587 or something. Yeah, it's not encrypted. So what this actually will do, if you have a PCAP of people doing that, which an amazing number of people do, I would say the majority still send their email unencrypted. So when you come in here, it'll basically pull up like a Gmail style email client in here to where you can actually click and read email, only you're doing it out of a PCAP file. If I was really planning ahead, I would have had like an email I'd sent or something like that. But so yeah, all sorts of stuff. You can also, this is the other fun one, you can download VoIP conversations. So that's a good time when you have people chatting, especially if it's over a particular, many of the IM sort of clients you have that do voice are often not encrypted. So that's a thing. Documents sent to printers over, what's it, LTP, or whatever that acronym is for printer sockets. You can just download the document here. Or what's MMS? Not Facebook. Yeah. It's so SMS is strictly text messaging. MMS is multimedia messaging. So whenever you send a standard, like, so not iMessage and not like Signal and not stuff like that, but when you just text, I usually use my parents as the example. When I get a picture from my parents, it's an MMS because they can't keep the settings on their phone to use Signal or iMessage. They can't handle it, so that's what I get. So it can strip that out. Because you can relay MMS and SMS messaging through email clients. Like if you go deep into Outlook, I don't know why you'd ever want to do this, but you can actually set up Outlook on your computer to do texting, and then you have to pay some service provider fee. I assume that's like when you drive around town and you see, for more information, text like new house to this short code. There's probably someone sitting there treating text messages just like emails. So when you text in wanting info, it pops up as an email on their computer. Then they reply and tell you, oh, you need this new house really bad, or whatever it is. So that's probably where we see those. Some dated chat protocols. Well, mostly MSN and I'm assuming Yahoo Messenger is super dead as well. That's not one I've looked into much, but splits those apart. So lots of good stuff inside of there. So I'm just gonna kind of keep rolling now. What time is it? Quarter after, yeah. So let's assume we got data to come in. That's what we're gonna go for. So the security engine has its little file system for storing information about what all's going on. That's great. We're not going to read a lot of this in like raw format though, because otherwise we would just use Wireshark. So a couple tools that are of relevance to us. First one we'll open up is ELSA. So ELSA is essentially an open source Splunk. So when we open this up, the interface is not going to be quite as pretty as Splunk, or even maybe so far as to say easy to use. But the perk of ELSA is that you don't have to pay for it. So if we come in here and start looking for, I don't know, it has some basic predefined queries, and then you can start to build them out. So if you wanted to see the top source IP addresses that were allowed, that were DNS, you can start to piece all of these together. Only I expected to actually have results, so maybe I didn't end up loading traffic in here. Whatever you set it to be when you ran through the wizard. So mine is Kyle with the old password one bang, but I'm guessing that won't work for you. I'm not a huge gambler, but I would put money on that probably not working. So, well, ELSA doesn't appear to be loading anything for me, so let's go on in our adventure to Sqguil. So, Sqguil is basically a GUI interface for interpreting snort events coming off. So Snort's really good at analyzing traffic, or Circata, whichever is running. So it generates all these events. Well, that's basically the equivalent of saying like, well, you just ran a piece of software to generate lots of logs. Great, you haven't really done yourself a ton of favors yet. So if you open up Sqguil, it's going to ask you what interfaces. I'll just do a select all. So what Sqguil will do is actually eat up the logs that are generated by Snort. So even further, make this a little bit bigger. What's something I don't care about? I don't care about the date timestamps. Now, I will say Sqguil's interface is not without its quirks, but it is a really good way to start filtering through stuff. So there's, if you end up working in a SOC somewhere, what's a SOC? Not like what you put. Yeah, Security Ops Center, not what you put on your feet. Sqguil is one of those tools that if you're like a first responder kind of person, so we have our firewall or our snort sensor, stuff like that, generating events. Sqguil is one of those interfaces that's like, that's probably one of the ones that you'll be using, or you'll be using something commercial that costs billions of dollars. But if you're using something open source, it'll probably be Sqguil. So Sqguil is neat because we can come in here and it has a rough indicator of how severe the particular event is. That's actually defined by the snort rule itself. So snort has severity rules in there. So this one, let's do this one here. So this rule came from ET, so that's emerging threats. So there's a set of snort rules that are out there that's like not necessarily a specific leet exploit. It's just here's a generic thing that might be of interest from a security perspective. So basically whenever snort, assuming you have this rule set loaded, has a activity on the VNC parts, it's going to fire this. So it tells us how many times, what actual sensor, which in our case is irrelevant because we only have one. And then these all have alert identifiers that are just kind of like primary keys for you to go look up the rule if you really wanted to. And then obviously, the basics that you can see inside of there. So what you can do is when you right-click along here, depending on where you right-click, you'll get a contextual menu come up. So if you right-click on the color, you can actually dismiss the events, or you can actually begin categorizing the events. So if you're working in a SOC and you're like getting tons and tons of VNC stuff, which if you're taking traffic, like can you imagine how many hits DSU has on potential VNC ports on our external firewall? It would just be obscene because we have so many IPs and just crap out there scanning all the time. So we could make an auto categorization rule to just make this go away. Or if we say, hey, we just want this event to go away, this is the job of a SOC analyst, is to go through all of these events and say, this one, okay, we have this event triggered. I'm going to look at it and say, this is something that needs to be escalated. Or this one I'm just expiring, so make a comment about like, I don't know, there isn't a VNC server. So do we really care about the VNC exploits coming at us? Not really. So then we make it go away. The other one it'll do that is very, very relevant for SOC analyst type positions is you notice the count column is what's CNT. So if you right click on that 3 and hit view correlated events, it goes through and figures out, hey, there's lots of these going on. These events seem to be somewhat similar. So here's, we're not going to show you 5,000 versions, or in this case 3 versions of this individual alert. Here's just one. We're going to correlate them all together. So that's cool. Then this one, I'm trying to think of a good one to actually play around with. There we go. So if we look at under the alert ID, if you right click on there and pull up the menu, and you have to like hold down the right click too, by the way, because I said the interface is weird. It's definitely an interface that's like made by the developer, and the developer's like, I feel that everyone should hold down right click, and the rest of the world's like, that's dumb, but that's what it is. So if you go to transcript, what that will do is tie into a tool called Bro. Actually, what did I pick? This is a DNS thing I picked. So what this tool is really good at doing is taking network traffic and just summarizing it in text. Now, my particular VM is not exactly super fast, and the traffic I happen to grab is not that super exciting. So nothing really great going on there. But it will give us text summaries of what's going on inside of there. You can also take an individual, this is where it's like super relevant now. So you can take an individual snort alert and then say, okay, open up that traffic that alerted you in Wireshark. So that's probably the bigger piece of this that's super, super helpful when you're actually tracking down network events that are going on, because you can go all the way back to the raw packet capture, which is why when I talk about Splunk and just doing log analysis stuff, if we were doing log analysis, we could get to like basically this interface and look at the events, but can we go any further? Not really. So that's the bigger picture inside of all of these. What else does it have? It's super annoying to use this on a laptop. So, oh yeah, browsers can open up text stuff and look for data files inside of there. So we'll let bro think. There's a couple other, like, you can go through checking like your own event history, so you can start to query stuff. You can build out queries by hand as well. So doing that is a thing, I guess, if you want to manually look up all these. The other neat thing is being able to pipe queries directly over to other programs. So obviously opening up ELSA and seeing like, hey, is there anything going on from this particular IP? But I apparently broke ELSA, so we'll just pretend that didn't happen. So, yeah, that checkbox can show that. That's nothing really exciting going on. We never actually looked at snort rules specifically, but you can actually see what they look like inside of there by showing the rule. So in this case, there are these ones up here are not relevant, like integrity checksum change. So this is all from me rerunning the wizard, so we don't really care about that. However, one of them is really relevant to us. Which one is that? Yeah. So the second one from the bottom, we see port 21, so FTP traffic, and we see emerging threats, exploit. So these are all the categories of the emerging threats alert database. So these are policy things of like, hey, you just shouldn't see things on that port. Eventually, emerging threats or the policy thing will open up like, hey, a new computer has appeared on your network. We've detected that this is not like the others. So that'll be inside of there. The final part is known exploits. So there is a particular favorite FTP server out there that is, I'm being patient because it can take some time. Particular FTP server out there that's vulnerable to has a ironic backdoor in it. Oh, I opened Bro. I want the text log because I don't care about the, there we go, transcript. So when we look at this, give us a second to load. It will pull out the transcript of the FTP traffic for us. So instead of doing like, at best we could do is like a follow TCP stream. So what this rule is, or particular rule and alert did is found the good old VSFTP 2.34, which in your username, if you included a smiley face, you would blow it up. So it couldn't handle the character sets correctly. So this is where we get like the server blowing up, doing all that. Or, well, we get someone doing an actual exploit attempt on the FTP server, which in the case of being in the SOC, doing analysis sort of stuff, we now see a GPL attack response. So what do you suppose is going on there? So we blew up the FTP server, and we wait for this particular response coming back. It's slowly loading it. This appears to be an unencrypted what? On the machine. Yeah, we have a shell here. So this is, yeah, correlating events back and forth, making them fun to discover. So at no point should you be looking through an unencrypted shell and find someone doing a who am I and it returning a root. That's typically frowned upon. So there are a couple things, though, that make this really, really hard right now to actually do in the wild. Any guesses as to what a lot of times folks are using Meterpreter? Guess what Meterpreter does that makes this kind of analysis really, really hard to do? Meterpreter ships with 100% more SSL now. So when Meterpreter does a reverse callback to you, it generates a TLS session and encrypts all the traffic. So finding specific signatures of Meterpreter stuff going on is rather hard to do. Finding just suspicious traffic going back and forth is really the only kind of bar for success that we have, because that is really the only thing we can do to actually figure out what's really, really going on inside of there. So, what's the other? Oh, there's Squirt as well. Anyway, that's some of the doings that you'd have inside of Sqguil as far as finding traffic that's relevant and stuff like that. The other one is if you open up the Squirt interface. Squirt is going to be a lot like Sqguil, only it's all web-based. So we find all these similar things that we saw inside of Sqguil. They're not like connected together in any way. They're two separate things. But we have all of our snort rules inside of here that we can do, whatever it is that you want to do. So all the rules come with certain classifications, so we can sort down, do all that good stuff. We can query it. I think you can even get charts and graphs, because who doesn't love a good chart and graph, right? So, oh yeah, that's right. So that is some of the tools you should be aware of for playing around with this stuff. Does anyone have questions? They're basically all showing you the same information of this IP did this on this port at this time from this sensor. That's why I'm not going to go through like every single little thing, because it's all great information. But it's all kind of the same from one tool to the other. So no questions. So I think what we will be left with for our class is playing around with VPNs. So otherwise we have kind of wrapped up the traffic analysis-y kind of things in a bit of a hurry. And then we'll do a couple days on crypto and VPN. And then guess what? Yeah, then we're done. So that's a good time, right? So with that, we will see y'all on Thursday.